Okay, now I have the distinct pleasure of being able to introduce our speakers. We have Evan Drumwright and Sam Zapolsky, who are the co-founders of Dextrous Robotics, and Suzanne Drumwright's also with us, who is their Chief of Operations. I am so excited about this. It's going to be a great presentation. I'm just going to turn it over to them because I don't want to mess up any of the technology explanation because that is not my forte. So I'm going to pass it on to you. Here you go. Thank you very much for doing this for us, y'all.
Thanks, Pearson. Okay, so we're Dextrous Robotics. We're building versatile robots for logistics applications. And we're going to start just with some introductions, us and our backgrounds. I'm the CEO, Evan Drumwright. Background, grew up here, got educated here, did my undergraduate, got degrees in computer science and also math from University of Memphis, went to USC, got my PhD there in robotics, and then just kept pushing the state of the art in robotics wherever I could. So I started with Honda Research Institute. I then became faculty. By the way, this was the thing that I worked on. This was so cool back in the day, and now, of course, there's new cool stuff. But yeah, I was working on the brains for this robot, Asimo. And after I did this at Honda, then I was faculty at GW in DC, and left in 2016 because Toyota Research Institute, where I went to, got $1 billion to do robotics. And up to that point, it had felt like robotics was just not going to happen. It seemed like, the major happenings were at the academic level, but we never had the money to really do stuff. So I said, okay, Toyota's going to have all of this money, and so we're going to be able to do great things. And so I went there. Technical expertise, and that's only relevant just because it goes to what we have built. I am one of the world's experts in robotic simulation. I'm probably one of the top 3. And I'm also really good at robot control and robot dynamics, robotic manipulation. We push the state of the art in these areas. And as a matter of fact, Dextrous now has the most advanced robotic manipulation, I think, in the world. And we're going to show you some evidence of that. So next is Sam.
We're introducing ourselves.
Yeah.
Okay. Hi, I'm Sam Zapolsky. I have a history in economics and international affairs in my BS program at GW. And I have a PhD in computer science from GW as well. Evan and I both worked at Toyota Research Institute. And when I was there, I worked on robotic shared autonomy, as in when you teleoperate a system, how does it keep itself safe? How do you interact with it in a way that it doesn't damage itself or its environment? And during that time, I developed several different robotic platforms and developed software to control them. And with that, I'll just pass it on to Suzanne. Yeah.
Hey, I'm Suzanne Drumwright. I'm the Director of Operations here at Dextrous. Before my time at Dextrous, I was in marketing and advertising and had my own firm for brand strategy, and that kind of helped me know some things about setting up a business. So happy to be on this team supporting our amazing engineers.
So what Suzanne isn't telling you is that she keeps basically every aspect of this business running except the engineering, which of course is our bread and butter, but you can't just make a company run on engineering alone. Our team, geographically distributed. We've got people as far away as the UK. We've got people on site. A number of our engineers are today working at Armstrong, which is about 25 minutes down the street. We're a startup. We have one of our first pilots going on at Armstrong, and so that's where most of our people are. The sole exception to this is Jess Moss, who is sitting right here and is probably mortified that I'm singling her out. So how did we come to start this company? Well, at TRI, we were working on a robot, and this was super cool at the time. I don't think I've had the good luck and also maybe a bit of skill to pick out good teams and good projects to work on. But we were working on a robot that loaded and unloaded a dishwasher autonomously. And so this was obviously more manipulation work, manipulation being everything that we do with the hand. And this robot was very impressive. There had been nothing like it seen at the time. It was able to pick all sorts of flatware and plates and bowls out of a sink, load them into a dishwasher, and do the reverse as well. So I was working on this, and like I said, was working at Toyota. We had all of these resources, $1 billion, and I was like, "This is it. This is what we come up with." To me, this was just not. It was impressive, but first of all, it wasn't super fast, which I like. Really, I think the fastest robots are the coolest robots, and more importantly, it really didn't have, in my opinion, any real impact on the world. So it was not really going to make people's lives discernibly better to have a robot mat in their kitchen loading and unloading their dishwasher. Now, you may disagree, but I don't mind loading the dishwasher so much. So that was kind of the first, one of the first things I saw was a little bit of dissatisfaction with what we were working on. And then another big thing was technological change happening. And you guys are seeing this and experiencing this today. This is a plot basically showing, and I don't know if you've kept up with technology at all, but NVIDIA, their chips keep going faster and faster for doing AI processing. And so what Sam and I noticed was that you've got these chips making AI processing happening so much faster. You've got better cameras coming out every single day, and you've got better algorithms, what they call neural networks and various other machine learning tools that keep getting better every single day. The big problem in robotics up to that point wasn't how we control the robot, it was how it perceives its environment through vision. And so we said, you know what, if we build this company now, then the vision is going to be where we need it to be by the time we need it to be there. And that has absolutely proven to be the case. And Sam will tell you a bit more about that in time. So we created Dextrous to solve some of those shortcomings in that last project that we worked on, which was, make an impact on the world. So we wanted to be able to help humans with tasks that were very intensive, so very physically intensive, heavy, also tedious, all kinds of manual labor, and we wanted to do it with fast-moving robots because they're cool and we like doing that. So that was what we sought out. That was what we sought to do, and we did some looking around. At the time, we were looking to see. So we were in Silicon Valley. We were looking at what was being funded, and logistics robotics companies were getting funded really well. And so we started looking into this, looking to see what we could do. And what we found was there was a task, which is called floor unloading, that was completely untapped. Nobody had come up with any kind of automated solution to deal with it. And just so you understand how this works, the task itself is really simple. You probably know somebody being in Memphis that has done it. You've got a truck that looks like this. All you need to do is get all the boxes out of the back of a truck. Now, it's typically way too hard for existing robotic systems to do that work in factories because they don't know what is coming in the truck. They don't know where it's going to be located because the trucks get shaken up. And that kind of uncertainty has just made it impossible up to this point to automate. So that was what we were looking at, and we discovered, hey, there's a big market in this. So there are 3 million package handlers doing this task in the US alone. If you assume that each one gets about $50,000 in direct and indirect costs, each one costs a company about $50,000 direct and indirect a year, then you're looking at a $150 billion market in the US alone per year. And so we said, yeah, that could do it. And then, in terms of the human impact, it was very clear. People die doing this job. People get injured doing this job. The workers who are doing it, they gain no skills. There's no kind of career progression that they make lifting and throwing boxes. This is a task for a machine. So from the employee side, they clearly needed help. And from the employer side, they need help too, because you've got seasonal surges. I think, if you've known anybody who's worked at FedEx, for instance, you know that they hire a bunch of people around the end of the year. That happens every single year, and it's tough for the company to do. It's also got a lot of turnover. It's very difficult to recruit people to do this tough job. So we said, yeah, that's what we're going to do. And you will see in the news today a bunch of, for instance, humanoid robots that people are getting excited about. These companies are raising millions and millions of dollars to put general purpose humanoids out there. I have worked on humanoids. I can tell you that is the worst idea ever. So we know that the best robots are the ones that are purpose-built for a specific application. So that's what we set out to do. We looked at how we could unload and later load and do various other tasks in the space, and we designed a robot around these specs to be able to move a certain amount of payload, a lot, to be able to go a lot faster than a person, which is no mean feat because people are really good at this. And to be able to pick all sorts of items out of a trailer and to be able to do it from every single square inch of a trailer. It's really, really, I like to call it a moonshot. It really is one. It has been, companies have tried to do this for 5 decades and failed. And so this is what we set out to do. So this was a lot of this was my vision. I kind of setting the stage, I set out this vision for how we would do this, like the actual technology we would use to do this. But then the genius who made all of this stuff happen is our CTO, Sam. And he's going to tell you how he achieved this vision and what he built. And so now, Sam.
Thank you, Evan. Okay. So, thanks, Evan. So I'm going to show you a bit about what our robot is and what it does. So let me just start this video quick. So our robot can be best described as a bimanual manipulation platform. It's about a 7-foot cube in dimensions, and it freely positions 2 very large chopsticks, which are about the size of pool cues, in that 7-foot cube, and it does so very quickly. And it moves about 10 feet per second, as in it can cross its entire workspace, which in this case is a truck, in less than a second. And that means it can unload, it can pick and place a box in just under 2 seconds. It's fast, strong, versatile. It's really the best robot I've seen in my career, and I'm really happy that we're the ones that actually made it. And it's capable of moving about 88 pounds at 3 Gs. That's like a small kid on a roller coaster. It's about 260 pounds of force that it can apply while not moving very quickly. And it's positionable to 0.2 of a millimeter, so it has very high accuracy. And it's all backdrivable, as in it can be made safe for human interaction. That is supported in hardware, but it is yet to be supported in software. So specifically, this robot does contact-based manipulation. And specifically, that's the kind of manipulation you do when you squeeze something and you use friction and touch instead of either supporting something from the bottom or using suction or supporting something from the top when manipulating. So giving an example of what contact-based manipulation looks like, this is mostly state-of-the-art performance of this kind of manipulation. This took a team of 56 engineers at Google to do, and you can see it's a very hard problem. This is the state-of-the-art in contact-based manipulation as we see it in the Silicon Valley company. And to compare, I'm going to jump over to our video that we posted about 2 years ago. In this video, we have more than caught up with that team of 56 engineers with our very lightweight team of 6 engineers, where we did a prototype of this kind of chopsticks platform using robot arms. You'll see this is a simulation of the robot that is the DX1 that I'll show a bit later. And so you can see 2 years ago, we were already up to date with the kind of contact manipulation you see in state-of-the-art large companies with a very lightweight team. And from that point, it only got better. So this is our more recent video. And we've gone so much further than that first one. We've got our chopsticks platform, our DX1 platform, moving a very large box. It can move very large boxes, very small boxes, boxes out of clutter. And it can move multiple boxes at a time. And it is just a general manipulation platform that can really, is specifically designed for loading and unloading a truck and can do so very quickly. And you're seeing it's applying itself to all kinds of varied things. And this kind of variability in the picking application is just unheard of up until this point. So our robot is a reactive bimanual manipulation platform. This shows a bit about what our perception system can do. It can, in less than a second, dimension hundreds of boxes in its camera that it can see, and accurately find their location as well, and do so at such a high frequency that you see in this right image, one of our robots balancing a box on one of these chopsticks, and seeing it drift over to one side and moving the robot under it and rebalancing it. So that's a bit about our perception, and this just, anything you'd see at a recent trade show, this just blows it completely out of the water. You maybe see them dimensioning a single box fairly poorly, and not telling you anything about the position, and we can do that to hundreds of boxes in a single scene in less than a second, and get their positions as well. So, and we are able to repeat all of this stuff that we can do on the real robot on real cameras in simulation, which is a huge technological lever we use. Evan actually developed this simulator at his time at TRI, and we continue to use it and develop it. And on top of it, we've built a huge amount of robot control and planning software and perception software that allows us to make this robot work. And the advantage of using simulation for this type of application is that we're able to use any number of engineers, because robots are definitely limited in time. You can only have one person on them at a time. They, they risk breaking them if you go and put bad code on them, and you really can't run them remotely. So by making a simulation of it, we're able to get a much more diverse team from all around the country, and also right here in Memphis. So with that, I'll pass it on to Suzanne, who is making the rest of the company work. So here you go.
Hello. So earlier I had said if you build it, they will come, but they still have to know about it. So as I mentioned earlier, my background is marketing and advertising. So getting press releases out, getting brand elements and media assets together kind of came naturally to me. That was easy. But I also know how important networking and building relationships is. So I know I got involved with logistics organizations, automation organizations, business organizations like Epicenter, for example, to talk to people, tell them what our amazing engineering team is doing, and also hear what they need and hear their concerns and challenges and how we can help them, and build a business model and a pilot program that works for them. I learned from our vendors, like, okay, these parts are going to be the long lead times. The supply chain was a complete mess last year. So working with them to figure that out so we can get these robots built when we tell these customers and have our engineers be able to work on products and parts that they need when they need them. And with customers, a small to middle-sized warehouse looks completely different than a large logistics company, and we have to be able to serve both of those customers. So we were meeting them and talking to them and just making connections in the field. So that was a big part of it, and I've learned so much, and that part's been amazing. And we've built that into making a business plan that works for them. And so really the biggest thing that spoke to me was that's all Memphis. Like everything everybody was saying comes back to Memphis. We have the most medical device manufacturing here. We have the biggest logistics hub in the world here. So logistics manufacturing makes total sense here. The fabricators are here. The warehouses are here. So there should be more companies like us. We should be using fabricators here. We should be partnering with warehouses here. So I got really excited about making the everyday job not being a box thrower, but being a upskill job and building robots, maintaining robots, operating robots, having our kids exposed to these things early on, and you don't have to go to Silicon Valley or Boston to see that happening. And it can all happen right here. And I just really feel like the city's ready for it. And that's the part I'm excited about most. And I guess that also goes on to our customers and our first pilot, which is a Memphis-based customer. Armstrong has been the best first partner we could possibly have. Here's what you want to look for in an optimal pilot customer. We've built a robot that can do something better than medium-sized, boring square boxes. So we want a partner that we can move those. Armstrong has that. We want a good volume mix and close to our headquarters. Just today, half of our team's able to go down there and do some testing while they're unloading and continue learning. They understand the adoption of new technology, which is we are moving boxes and our robot is learning more, and we can add in features that are important to them. So as we talk to customers, what they want is what we can add on and build. So it's been I've learned a lot. It's been really exciting to watch it grow and build from there. And Evan will tell you what's next.
Okay, so we've gotten to this point. I think I said that trying to do this has been a moonshot. Frankly, I thought when we did this, we would get some money from Silicon Valley. We would do some really cool stuff, and it might or it might not turn out to be something that worked. And I didn't, I maybe gave us a, 20% chance of success or something. I knew what we were doing was so hard. Again, look at what Google did with a much bigger team. And Sam and I just put together this crack engineering team. We got people like Jess from all over the world to come and be part of this here. And this amazing machine came to fruition. And even as early as, say, January or February of this year, I still maybe gave us about a 50% chance of being able to make a product that was commercially viable. It's just so technically complex to solve. And now we've done it. So what we've now got this working at Armstrong. It works exactly like it worked in our lab space, which almost never happens. I think that's a testament to, our simulation, our secret weapon, also our engineering team. And next, we're set up to capture a really big package logistics company. It's under NDA, so I can't say anything about it. But, we have this piece of technology that not only can move boxes, which is, now there are a few other companies that have come around since we started that can do this, but can move all of these other things as well. And we're the only company in the world that is able to do this. And so we're about to blow off the roof of this thing. If you're interested in being a part of this, we're currently raising a little bit of money, $2.5 million. via convertible debt. That's, this is going to land that big customer. And yeah, we're just so excited to see this thing fly. And that's it. So I think now, if you guys want to come back up, we'll answer any questions that people have. Yeah.
First of all, I've been looking for a solution like that in supply chain material handling for only 28 years. So
Okay.
that's amazing. How easy is it to do implementation and how are you providing? Are you doing like a RAS process where you're doing sales, and then is it need or people have needs for peak times, like you said, when holidays are coming? Can you increase the number of pieces to match that? I have 1,000 questions.
Yeah, so many questions. Okay, so the business model, you mentioned RAS, so robots as a service is what it's called. So we have something that, because that term has kind of gotten overloaded in the industry, we call it per pick pricing. So you're only paying for the pieces that are picked. So it's been very attractive for our customers like Armstrong. And then, because it's very low friction to be able to try what we're doing. And, and that's important because this robot that we've built looks like nothing else that's out there. And so, yeah, you want to make it as easy as possible to get into customers' hands. The question about scale is a great one as well. So really the way we have designed this robot to be able to go so much faster than people are doing. We're not there yet. Those are coming in software updates. But if you need more capacity, the nice thing about a robot is you just add more of them. With people, you've actually got to go through a process, recruit, onboard, manage, terminate if they're seasonal. And with robots, you just add more. And because you're paying for only what you pick, it's kind of a no-brainer.
About
1,000 pounds. Right.
No, 1,000, 1,000.
Anybody else have any questions? Yeah, Dan?
Yeah, we mentioned that the robots are learning as it's working. So is it independent? Has it got an AI function so it can continue to learn from its environment? Or is that something?
Yeah, the robot is fully autonomous. Some of those features are not fully landed right now, but it is fully autonomous in that you open up the door of the trailer in this particular application, and you say go, and it sees the full stack of boxes. It decides which one it wants to pick next. It grabs it, it puts it on the conveyor, and then when it's cleared the entire wall of boxes in front of it, it drives just a bit forward to that next wall of boxes and repeats. And when it's done, it backs all the way out of the trailer. The robot drives itself, or can be self-driven, and it's fully capable of doing the entire job autonomously.
Yeah, but you asked about the learning. So that's kind of a dirty secret, I'd say, of AI today. There's no, you just set something out there and it soaks up information and it figures out how to adapt itself. There are some limited circumstances where you can do that. But for the most part, and this is, I think, why we don't have to necessarily worry about AI taking all of our jobs, you have to supervise the information that you give to machine learning, to AI. You've got to say, this is the thing I want you to get better at. This is the thing you don't need to care about. And so, yeah, you've still got a lot of engineering involved, at least initially, to get a product like this out the door.
Yeah. Are you doing communication with WMS? Do you care? Does it care? Do your users care about if it recognizes all the SKUs that it's uploading and keeping track, like a manifest unload? Or is that still done by downline by a person that can, one person can do, 15?
I feel like we've got two talks going on here. So what he's asking is, can the robot, so modern warehouses are outfitted with something called a warehouse management system. that allows them to basically use data. So it's not just all manual. They're actually tracking how fast packages are being, the intake rate of packages and all sorts of other metrics. And the short answer to that is no. We have not done any integration with the WMS yet. Part of the challenge of building a startup here is that the technical challenge that we've had to overcome has been so high. And the customers that we typically talk to, they call them elephants. We've been hunting elephants. They're so big that you're not doing contract negotiations with them quickly. And so one of the quickest ways to slow down the contract negotiation is to bring their IT into the mix. So that's kind of a multi-stage thing. I mean, the whole company is multi-stage. So we start with unloading. Later we add loading, palletizing, depalletizing. We are able, because of the dimensioning that Sam is talking about, we're able to distinguish different packages based on dimensions alone. If they're labeled but otherwise have the same dimensions, then we would actually have to determine that with computer vision. Easy enough for us to do, but we haven't had that feature yet.
But I wouldn't see a reason why you have to do this time.
Not yet.
This stage.
Yeah.
And even skew,
Yeah, so we're considered to be a seed stage company. We're like right on the cusp of Series A, and that's where this pilot with Armstrong comes in, and also this additional pilot with big unnamed package logistics company.
So really, these robots could do the sort at FedEx. I mean, they could bring in the things and eventually do all of that, couldn't they?
Yes, but to be specific, when you look at a company like FedEx and you look at their matrix, it's got a lot of operations going on in it. One of the biggest ones that happens is they've got shipments of trucks from all over. These are from commercial customers. These are from their FedEx delivery vans that pick up packages, and those packages have to be pulled out, put onto a conveyor belt, and sorted into their system. And then that's a big part of it, and that's one of the things that only we have the technology that can pick up packages with that kind of variability.
Where do you find your people?
We have found them a number of ways. We found Jess. That was somebody through my network that we found. We have found people through. Actually, let me let Suzanne answer this one.
Yeah, I went through the rabbit hole of contacting different colleges and found that a lot use Handshake. So that was one that we look at. And then also Epicenter in Launch, Tennessee, I let them know what jobs we have. We got a local intern this summer, and really just a robotics trade publication. LinkedIn. I think everyone came from a different source, so we can't say what works the best yet. We just try them all as affordably as possible. Yeah,
we're highly discriminating. I think that's the other thing. Like we are very slow to fire if we have to do that. We're very fast to fire if we have to do that. We're very slow to hire for that reason. Yeah.
As an engineer, what type of skills are you guys looking for, outside of this, advanced C++ programming? What type of skill sets are you guys looking for in your robotic engineers?
The number one thing we've looked for up to this point has kind of been multidisciplinary. Can they do, because we've always got a number of projects going on. And for instance, Jess is able to do, she came in being able to do mechanical stuff. She had, as I was reminded yesterday, had built her own electric motorcycle. She can code. She's been working on the electronic components of the robot, so that's a new skill that she's picked up working with us. So that's a typical kind of thing that we look for. We like people that can wear multiple hats. And then the other thing that's really important is not the technical skills, but cultural fit. Are they easy to get along with? We had a hire early on that was just brilliant person, but kind of didn't fit with the rest of us, and we tried it out, and we're not doing that again. So we're looking for technical excellence, multidisciplinary people that like our culture and can contribute back to it. Yeah.
In the world of robotics, which I'm not familiar with, I'm sure it's a huge business opportunity for the next 50 years in this country and other places. How do you describe your development as it competes with numbers of companies that are going to already competing with you? How do you position yourself? In other words, have you done that with the word Dextro? Have you done that with your title?
Yeah, so we are the world leaders in bimanual robotic manipulation. So using 2 arms and contact to be able to manipulate. We are the world leaders in that. I have not seen anybody come close to the speed or versatility of what we've done, which frankly, to me is amazing because there's been a lot of work in the past. Most of the work that is happening today in robotics is working with suction-based systems. So we're almost the sole company doing this contact-based manipulation. Now, the suction has its advantages. The main one is it's a whole lot easier to get started with. So if we had done suction, we would have had a product to market probably 18 months ago, not today. But after that, your problems start to abound. The suction cups themselves suck up dirt, water, debris in these typically very dirty facilities. They can't deal with permeable materials like canvas bags that are passed around these trucks very well. They can't deal with very heavy weights. They can't deal with a mix of big and small things. So we went this very hard path because we liked it. I mean, part of why we were able to get such great people was because we were doing something that we knew was hard and that they knew was hard. And engineers, they love a challenge. They don't want to come and, the best engineers, they don't want to do something easy. So that's been the secret, is that we've picked that area and we've excelled in it. And, wherever we apply our skills to, our technology to, it's going to be one of those areas where we're able to leverage that niche that we've built.
Where are your clients located?
All over. They all have warehouses in this area, which is part of the reason that we located here. But headquartered all over the world. Germany, Bentonville, Atlanta, Seattle. Yeah.
Oh, sorry, I was just I did have a question. In terms of your setup, I noticed that the conveyor belt's always right there. Is that typical, and is that something that the company has, and your robot moves in and out of the truck?
Yeah, so typically the way that this works is the company will have different types of conveyors. They'll have either an unpowered conveyor, or they may even have a powered conveyor. They may have a conveyor that's it's called a telescopic one. It can automatically drive itself into the truck. But typically they do that because if you're going back and forth, if you're walking like that, you're wasting a lot of time. So for efficiency, the conveyor should follow you into the truck, and that's the way the robot does it too.
Anybody else have any questions?
Yeah.
In terms of talent, San Francisco, Boston, Pittsburgh, they have a lot of robotics talent in there. How do you guys see that scaling and your operations? You guys open offices out there, or?
Well, all 3 of us just came from the Bay Area before we started this company. And the thing about the Bay Area is you've got a lot of talent, but you've got equally as many companies that are competing for that talent. So yeah, maybe we open additional offices at some point there. I think that's all kind of TBD. We've been really good at evaluating. The labor market has changed a lot over the past 3 years. It went from everybody's working at one place to people want to work remotely to, oh yeah, everybody's going to work at one place again. And I think that hasn't all sorted itself out yet. But it starts introducing challenges when you have multiple locations. And so we'll weigh that carefully when the time comes.
But you got so much here in Memphis, it's like,
We're really convincing.
It's so what we have been able to do is we've been able to, by virtue of building this thing that is so special, we've been able to, engineer, like I said, engineers like working on fun, cool stuff. This is the coolest robot Sam's ever worked on, coolest robot I've ever worked on. Guarantee it's the coolest robot Jess has ever worked on. And people like, roboticists like to play with their toys. So, you got a big advantage there. Yeah.
Also, like, none of these people have been to Memphis before they came here, and it's been really exciting to see them fall in love with the city and like different places they go. Like, Jess introduces me to new things, and I'm from here, so it's been. The people that have moved here love the cost of living, love the places they're visiting, and just the grit and the culture that Memphis offers is really special, and it's exciting to see new people see that and bring them here.
Yeah, love the lack of commute too. Sam lives a 5-minute walk. Yeah. Most of the rest of us, I think, are just a short drive away. So that can appeal to people. Yeah.
Can you share what is your dream for the company? What is the biggest dream?
My dream for the company is to be able to keep making stuff that impacts the world in a positive way. That is doing these things that are causing people physical pain and suffering, and also is a bit of magic. So we had an article. We've got an article coming out in a robotics-focused trade publication. Their national IEEE Spectrum will be coming out within about a month or so. And the robotics editor, somebody who really knows his stuff, said, "How did you do this? Like, this looks like you've got a person behind the scenes making this work." And man, that was so gratifying to be able to, blow his mind like that. Man, that is so gratifying. So yeah, that's the kind of thing that I look for.
Wow. Thank you so much. Thank you very much. This is very exciting. I think they're going to be able to grow into this space. They've got a huge warehouse, as you can see through the window over there where the machine is working today, so we don't get to see it in person. But what a great facility you have. We are so thankful that you're here in Memphis. It's just it's such an exciting company. So thank you all for being here. Thank you. October 10th, I think the 10th is with Bill Courtney. If you've never heard Bill Courtney's story, he's amazing, and he has a new podcast called An Army of Normal Folk. He's the guy that was the Manassas football coach, has classic American hardwood. So he's going to be our October speaker at CHAR. Hope that you'll be there then, and thank you again.
Thank you.
Thanks, Pearson.
It was so great.